Thank you to be here. Let me start now with a possible exam exercise. If you remember last time, we started with maps and we did some exercises. Look at this exercise. You can copy. And we have also the first question. Think about a couple minutes. And then I read for you. Exam exercise. Let's consider the following linear map. T indicates the transformation. The linear I don't know if you remember, the linear map is a transformation. The linear map is a function. Linear, very important, is a transformation from space. About space, you remember I told you a lot. About space, I told you a lot. About space, R up to 2. In another space, R up to 2. This means we have the domain and the codomain, or better to say, the image of this transformation, which have the same dimension, R2, the dimension 2. And I'm giving you, let me say, two information. The transformation of the point 1, 6, or better to say, the point 1, 6 of the vector 1, 6 is transformed into 1, 6. And the point 1, 3 transformed into 1, 5. This is the data. Then let me see. We have two questions. The first question is, please build the map with its analytical structure. Describe mathematically the map, basically. The second question is, calculate the kernel of this map and say if the map is injective or is an injective one. About the injectivity, I don't remember if I already defined. If I didn't define, we can skip this last question. But I think I told you about the injectivity. I don't remember really. But if I didn't tell you about the injectivity, we can consider now. Do you remember if I told you? You don't remember.
What is this question again? Calculate the, can you read it out sentence?
Calculate the kernel of this map. Let me start with the first question. That we need. I think I told you about the kernel. If no, I will come back to the presentation and I will consider. Let me show you. Let me look. Question? We will look about the injectivity later, but I think I told you. But if not, it takes 1 minute to define the injectivity and to show you the property. Okay, let me start answering the question number 1. Look, it is the transformation, as I told you, between R up to 2 to R up to 2. And in general, this transformation can be written in this form. T of what? Parenthesis x, comma, y, parenthesis. This means everything in the plane xy. Let me close the image. Now, everything is the plane xy, plane, excuse me, with two dimensions, x and y. You have to remember, from the school, x and y, two dimensions. Is transformed into a linear combination, and therefore linear transformation of element x and y. And what is the general form of this possible linear combination in two dimensions? A multiply x plus b multiply y, first component, comma, this means c multiply x plus d multiply y, second component, in which a, b, c, d are parameters which belong to R. It must be calculated. I mean, this is very important consistency. The word linear is exactly explained or reflected, better to say, here. Is the linear transformation of element of x and y, which maps element of x and y into a space with dimension 2, 1 and 2. And inside this space, we have the all possible linear combination of x and y. We can see here a multiply x plus b multiply y, comma c multiply x plus d multiply y. All possible combinations. I don't know if this explanation can be understood. I have a different parameters, a, b, c, d, for all possible linear combinations between element on x and y from space R up to 2, or R2, let me say, to R2. This expression here is the general, let me say, interpretation of the first part, in particular linear. Now, practically, I have to calculate A, B, C, D. No? It's a little bit boring, we can see, but it's an exercise which you can do from your knowledge in high school. But let me do together or explain together these boring calculations, but extremely easy. Why this line, or this condition? This condition came looking at the data, very important in math, very important in our life, the data, which I have. What I have? I have that 1, 6 is mapped into 1, 6. It's written here. The transformation works so 1, 6 equals 1, 6. T of 1, 6 equal 1, 6. 1, 6 is 1, 6 in the sense, the vector 1, 6. No? Is transformed into itself. This means this. How I can explain with words. This transformation works in this form. 1, 6, just this point, is transformed into 1, 6. Okay, it's written here. How I can use this information? Look, if you look at this expression, I have this. X is equal 1. This means A multiply 1 plus B multiply Y. Why X is equal 1? Because X is this 1 in this case, in this information. X is equal 1 in this information. Y is equal 6 in this information. Did you agree? X and Y represent the domain. X is equal 1, Y equals 6. Is transformed into 1. This means A multiply 1 plus B multiply 6 equal 1. Why that? Because this element here is 1. This is the first element of the codomain. Image, better to say. Look, this element here, everything which is written here is 1. Look at this, x, comma, y equals something, linear combination, comma, something. This is equal or correspond. This means 1, 6 in the domain, 1, 6, multiply A, multiply B, as is written here, equal 1. Why that? Because the first element of the image is here. If you don't like this equal, try with arrow. So it's everything consequent, but arrow is the same like equal. In this transformation, this mapping, equal is the correspondence, but could be interpreted also as equal. To solve the problem, I would like to use equals, because if I put here arrow, practically, okay, we can, if arrow means equal, you see. Now, once understood, we can interpret it also this. I am using here 1 and 3. 1 and 3. This means I am using the second element of the domain. Look, 1 and 3. 1 and 3. I am using the second element of the domain, which is equal 1. It's good. The second element of the domain is equal 1. Once transformed, of course. Once transformed. E infatti sia, no? A plus multiply 1 plus B multiply 3 equal 1. Now, I already considered the domain 1, 6, let me say so, 1, 3 as a vector, and their X transformation. Now I do the same for the Y. This and this. Easy. Because C multiply why I am considering C? Because now I have to consider this. The Y element, the general second element, Y element is a little bit strange because Y is here. The general second element of the image is this. This means C multiply 1 plus D multiply 6, because I am considering this again, this element here. Now is equal 6. It's difficult. It's difficult. Why that? Again, because X equal 1, excuse me here, X equal 1, X equal 1, please fill the problem. X equal 1, Y equal 6, in the context of the codomain is equal 6 once transformed. This means the transformation of the second element is here. This means C multiply 1 plus D multiply 6, 1 and 6, 6, no? 1 and 6, is equal 6. Now I do the same here for this data. 1, 3 in the second position is transformed into 5. This means C multiply 1, the second position is always this, no? C multiply 1 plus D multiply 3 equal 5, because of this 5. Think 1 second. Here is the key point, the difficult point. The difficult point really is to build this system. Difficult? Question. Probably I have to answer your questions. Probably I have to answer your question. How is difficult here? How,
I personally just need some time to do.
to calculate, okay. let me go ahead with the calculation, then we will do other exercises. Okay, this is a good idea. Now, from here is the exercise from gymnasium, no? Because look, for instance, from the first equation, I can write as A equals 1 minus 6b, no? From the first equation. A equals 1 minus 6b. From the second equation, if I plug in this expression here inside, I have 1 minus 6b plus 3b equal 1. From here, we have that b equals 0. Now, plug it in substitution methods, probably you know from Japan. No? It's boring, but it's okay. From here to here is clear, no? I write what A is from here. A equals 1 minus 6b. Then I plug in A here, and I have 1 minus 6b plus 3b equal 1. And from here is clear that b equals 0. Easy, no? Because we have minus 3b equals 0. If b equals 0, from the first equation, I have A equal 1. I already calculate A, and I already calculate B. I do the same now for the second part of the system, which we can see from here that C is equal 6 minus 6B. Just looking at this equation here. No? Now, if I plug in C here, I have a 6 minus 6D plus 3D equal 5. From here, doing the easy calculation, we have D equal 1 divided 3. Look a little bit. If D equal 1 divided 3, I can plug in here, in this equation, I have a C equal 4. Think about 1 second. At the end, I have A, B, C, and D. Now, if you look at our general map, I can write directly, explicitly, the transformation. Because the task was at the end, after our interpretation, the task was to calculate A, B, C, and D, which define these 4 elements, define the transformation. Questions? To calculate A, B, C, D from Gymnasio, we can do a little bit, we have to do a little bit exercises, but yeah. The first question is already answered here. We have concretely or explicitly the transformation. What is the meaning of the transformation? For each x and y, I know exactly where in the what the transformation does. I mean, look, the point 1, 0, for instance, to understand, the point 1, 0, 1, 0 is transformed into 1, 4. No? This means I can map every x and y, no? Because I have the law, or if you want, the transformation. No? Law, transformation, function, no? Everything is the same meaning. Question? If no question, let me proceed answering the question number 2. And let me reread the question number 2. Calculate the kernel of this map and say if the map is injective one, is an injective one. We will see later again the definition of injective. No? We will see exactly now the definition of the kernel. Probably you don't remember. The kernel of a transformation is the set of the domain which annihilate the transformation. What is the meaning of annihilate? It's the set which is transformed into zero. Kernel means a set of the transformation, a set, excuse me, of the domain which is transformed into zero, right? Kernel is easy. Everything which is going to zero. This set is called kernel. Now, here, I don't know if you remember, at the end of the lecture of last time, I introduced the concept of the representation of a transformation in form of a matrix. This means this expression here is equivalent to this. Is equivalent to this. It's very important, this concept, because I was extremely boring introducing matrices, property of matrices, and so on. And in engineer fields, the matrices are more used than this expression here. Why that? Because with the computer, because for the calculations, to represent everything in a table is more effective. Look, first concept, this expression here, please pay attention, this expression is equivalent to this one. I don't know if it's visible. I see perplexity. Okay, do you remember the rule, excuse me, row multiply column? When we have the product between matrices or matrix and a vector is also a matrix. If you do this, multiply this, I have X. This is our original transformation, right? What we calculated until now. This is clear, no? Where this comes from. I calculate A, B, C, D.
But why is T actually just Y and not one third?
Yeah, because I made mistakes. Now it's better, no? In fact, if you do row multiply column, I have 4x plus y divided 3. Now, excuse me for the error. But here is correct. Do you remember we calculate A equal 1, B equal 0, C equal 4, and D equal 1 divided 3, right? This was the calculations. Okay? Now, look, row multiply column. Did you agree that you have a vector which is characterized by x here, row multiply column, and the second component is 4x plus 1 divided 3 multiply y. Now it's clear that this expression equals this expression. Or is not clear? It's clear. Now, look at the kernel. The kernel means to calculate x and y such that through the transformation, x and y is mapped into 0, 0. The transformation of x and y is mapped into 0, 0. But this problem can be solved mathematically. Why that? Because again, row multiply column. This is a little bit explanation. Means x equals 0. Row multiply column means 1 multiply x plus 0 multiply y. This means x equals 0. Second row multiply x and y means 4x plus 1 divided 3 multiply y equals 0. This means y equals 0. No? Because if x equals 0, we have also y equals 0. This means the kernel of T, which correspond to the null of kernel of A, matrix and transformation, for us are the same thing. Is 0, 0. Please pay attention. There is directly in the conclusion, and then we will discuss the conclusion together. The conclusion says the transformation is injective. And then there is here the explanation, because if you look at the lecture of last time, I told you about this theorem. If you want, I come back now directly on to the lecture, to the slide. We have seen in the theorem, the theorem says that a linear transformation is injective. Please pay attention. If and only if the kernel of T equals 0. Aspettate, just 0 is transformed into 0. I don't know if you remember this theorem. It was at the end of the presentation, without demonstration. It's easy to remember. Why that? Think about a line. What is a linear? Please pay attention. A linear is in a line. We have a line. Linear is in a line. Yeah, but we have a linear transformation if and only if the line is through 0. Otherwise, you remember I told you affine transformation, not exactly linear, and so on. If 0 yeah, this is a little bit the answer related to the second question. Let me see if I forgot to say something. Yeah.
Last part
In fact, we have a theorem which we have seen last time. And the theorem says to us that a linear transformation is injective, which says, which says that the linear transformation is injective if and only if the kernel of this transformation is equal to 0. If and only if means 0 is transformed to 0, and if the linear transformation, just 0 is transformed into 0. Or better to say, if 0 is not transforming to 0, is not a linear transformation. Basically, you can say just element 0 is transformed into 0. Now, another exercise. More difficult or the same level to do exercise? The same level. This is exam. I mean, if you need to do a little bit exercise, I do more or less the same. If what I told you until now is not clear, I would like to do another exercise, but a little bit different, but with the same level of difficulty, quite similar. It's clear. Okay. This means I try to find another kind of exercise with some more challenging, but not much difficult. Everything is already explained. We have to adapt this knowledge into different situations, something like that. Okay, let me look. If you look at the lecture last time, we have seen also last time. Yeah, okay. Look, look at this second part. Let's consider the transformation team from R up to 2 to R up to 3. With the same two questions as before. Build the transformation, calculate the capital, and injectivity. Again, the question is, or the questions are the same. Build the transformation, calculate the capital of the transformation once we have a transformation. And then at the end, discuss the injectivity. Here, it's a shade a little bit boring, but you can see that I'm not so bad. I put a lot of zeros in the data. This means the calculation, even though boring, can be done. Look, I'm not so bad. I'm not so bad. In the exam, in the text, I will write also this indication. Please pay attention what I will try to do. This means the interpretation, the most important interpretation, or one of the most important interpretation of the problem, is in the text, because this sentence here interprets that the transformation, more concretely, that the transformation works from R up to 2 to R up to 3. This indication, T of x comma y, parenthesis equals a multiply x plus b multiply y, comma c multiply x plus d multiply y, and so on, interpret exactly that t is from R up to 2 to R up to 3. Inside. Now we proceed as before. Should I, may I go ahead? Yeah, this is interpretation. Huh? A little bit strange what I am, but it is relatively easy. I try to explain. Why at the beginning I wrote A multiply 1 plus B multiply 1 equal 1, as before. Because I have 1, 1, please pay attention, 1, 1, x equal 1, x equal 1, y equal 1, which is transformed, is 1, 0, 0. In particular, I have, if you look at this, I have A multiply 1, A multiply 1, plus B multiply 1, y plus B multiply 1, because y is 1. Y is 1. Everything is equal 1, because this element here is the first element of this vector. Again, x equal 1 means A multiply 1. Y equal 1 in the domain x and y means plus B multiply 1 equal 1. Why that? Because this element here is the first element of this vector, or the first element of the image. Yeah. Then I do the same, and then from here directly, we will see later what I can calculate. But at the beginning, forget this. No? Very important is what we have here on the left part. And then we will see how we can quickly look at the right part. Please look just at this. Second line, why is C multiply 1 plus D multiply 1 equals 0? It's easy. Because C multiply 1 come from here. C multiply x equal 1 plus D multiply 1. And I have to consider this point, which is 0, or this element of this point, which is 0, because we are in the middle. We are in the middle of the domain. And then we understood the line 3 is E multiply x equal 1. This means E multiply 1 plus F multiply, excuse me, x is 1 is here, no? This one here, the first one. E multiply x, which is this 1, 1, plus F multiply y, which is 1, equal what? The last element, the third one, equal 1. And so on for the rest of the data. And we have these expressions. At this moment, don't look this. No? We have this expression. Very nice, that, excuse me, we can see that starting from the line number 4, we have some zeros, and this can help in the calculation. In the exam, I will try to put many zeros. So we don't have to do many calculations. I show you a little bit better. Now, the procedure is okay. It doesn't matter if we have R up to 2, R up to 3, could be a little bit boring. Don't care about this, not at this moment. Then I clarify how quickly we can calculate. In any case, I can list, please attention to what I am saying. I can list the conditions. Try to copy or try to do alone better, and then I explain how we can calculate directly A, B, C, D, and so on. Now, if you look at the first at the list on the left, we can see, for instance, that for the line number 4, thanks to the 0 here, I can say that A is equal 1. From the line number 4, I can say that A is equal 1. Clear, no? From this information, thanks to 0, I can say directly that A equal 1. But if A equal 1 from the first line, I can say that B equals 0. Because I plug in. Do you remember in high school, plug in? You can use all knowledge which you have in math, because here we are a master. From this line here, thanks to this 0 here, should be here, I can say directly that A equal 1. But if A equal 1, I can use here. But if A equal 1, B is equal 0. Then if you look a little bit at the equation where we have the zeros, it's easy to calculate. Believe me, this is an exercise from high school to look how I can calculate quickly some parameters and then use this parameter where they are in some other conditions. This is not the topic of master engineering. Look, this example is quite good. This is the equation number 4. But you can look also here. The equation number 5, the same concept. C directly is equal 1. C is equal 1. Now, if you plug in here, C is equal 1, I have it as D is equal minus 1. I don't know if it's visible. This means ideas with idea. Look where the zeros are and try to calculate quickly some parameters that can help to calculate the rest. And then, in this sense, we speak about an acceleration of the calculations, because it's an cumulative. If you know more parameter, you can proceed really quickly for the rest. Now, assuming that we understood, but I think it's no problem. We have everything: A, B, C, D, E, F, 6. Yeah, 6 parameters. Oh no, here we have a problem. Yeah, I clarify what I intend. No, I didn't see. Interesting. Look, that it seems that therefore this question. Look at what's interesting in this case. It seems that, for instance, here for D we have a -1, and we have a D equals 0, and also in E I didn't realize at the beginning is equal 0 here, and E is equal 1. Ah, interesting. We calculate the value, but we have a contradiction. Yeah, this is a little bit in a particular case, excuse me. We are able to calculate the parameters. As I told you, until now, everything is okay. But why I put this question here? Because it seems to me that we have 2 possible solutions. One for D and one for E. Conclusion in this case, we are not in the presence of a transformation, because we cannot determine univocally the parameters. This means no answer. I cannot build the transformation. Let me show you a little bit. Yeah, it's the case. It's in a particular case in which I cannot answer the question because we are not in the case of a function. Because I have two possible transformations. Let me see. Yeah, this is a particular case, but at least we have seen a little bit how we can build this condition and how we can solve. Okay, let me take another exercise again. In this case, in case we have two possible solutions, because we have two possible solutions for D, two possible solutions for E. Really, we have four possible transformations. If I can consider all possible combinations, but the transformation must be one. Otherwise, we are not in the presence of a transformation because we cannot determine ones. Let me consider now something with the solution. That will. Let me look. Yeah, found it. Look at this. Now here we have a solution. I think we have a time to do this exercise. No? Look. We have now time to do this exercise. This has a solution. Again, calculate. The questions are always the same. You know? Build mathematically the transformation T, and then calculate the kernel, and discuss the injectivity. The data is here. The transformation of 1, 0. 1, 0 is mapped into 1, 2, 1. And 0, 1 is mapped into 0, 1, 1. It's a transformation from R up to 2 to R up to 3. And again, the interpretation, the more explicit interpretation, T of X, comma Y is equal, now we know everything about that. No? AX plus BY, comma, CX plus DY, comma, EX plus FY. This is in the data, in the exam text. Then look, how I can interpret this. First line, X equal 1 and Y equal 0 in the domain. Here. X equal 1 and 1 equal 0, and Y equal 0. This means A multiply 1, we are here now. A multiply 1 plus B multiply 0 equals the first element, because here on the right part, let me say, of the equality, like here, we are in the first element. This means must be equal 1. going ahead. What happens here? Happen that C multiply 1, x is equal to 1, we can see here, plus D multiply 0 equals the second element 2. And then we proceed down, let me say so. But also here, thanks to the presence of some zeros, for instance, from this line here, I can calculate directly that B is equal to 0, thanks to the 0 here and the 0 here if you want. Now, if B is equal to 0, I can see where I can use. No, I don't need to use because it's not here. No, it's not present. I cannot, I mean, I don't need B. But B is equal to 0, I need the value. I don't need B for further calculation. Look here. From this line, we have E equal 1. From this line, we have it C equal 2 because of the presence of the 0 here. Because of the presence of the 0 here, we have A equal 1. Extremely easy to be calculated. Because in each line, we have something which is multiplied by 0. This means I have A equal 1. We can see here. B equals 0. Therefore, we don't have here any Y. C is equal to, we can see here, no? Look. C is equal to. Isn't it? D is equal 1 from here. B is equal 1 here. No, excuse me. D is equal 1 here because D multiplied by Y. E is equal 1, which is multiply X in the third position. And F again equal 1. This is the transformation. If this is the transformation, this transformation, if you remember, this transformation can be written in this form. This was difficult to remember, but I recalled to you today. No? This transformation can be written in this form. This transformation can be written in this form. This transformation can be written in this form. Do you remember the matrix form? Row multiply column. Huh? I told you, row multiply column can be written in this form. Then, what about the kernel? The kernel is the set of the element of the domain which is transformed into 0. This means this is the transformation. I will calculate X and Y, the element of the domain. The domain is R up to 2, no? Which is mapped into 0, 0, 0. Now we have to calculate X and Y, element of the domain, therefore in the domain R up to 2, which is transformed into 0, 0, 0. This means I have to solve this problem here. But if you remember, row multiply column means X plus 0, Y equals 0. This means X equals 0. 2X plus Y equals 0, which is written here. and x plus y equals 0, doing row multiply column. Everything, this means in the system structure, must be solved. This means x equals 0, but if x is equal 0, y is equal 0, and then 0 equals 0, show our consequentiality. This means the solution is x, y, 0 equals equal 0, 0. We have just one solution. This means in general, if and only if just 0 is into 0. Let me, in these 5 minutes, look if I have a transformation not injective to find what.
Wasn't the first one did not injected? Like the one we saw? This one? So the 9 rows, where is in this one is the 9 rows. And we have the most three.
No, this is no solution. That the transformation does not exist univocally.
Okay, if there's no function, it's not segment.
Yeah, I exactly no function. I told you last time in the case not injective, I mean with the kernel not 0. Let me see if I find one here quickly. I hope that I find it. Probably here. Yeah, found it.
So it's the same.
Look at this. Look at this. Transformation from R up to 2 to R up to 2. We did that. The last one, we have 5 minutes. I think that is not injected. Let me check again. One second. Mhm. Okay. If this is the data, again, I can build as before these 4 conditions. Just quickly. A multiply x equal 1, we can see here, because of this 1 here, plus b multiply 4 because of this 4 here, equal what? 1. Why 1? Because we are in the first position. Then we have a c multiply x plus d multiply y. This means for x equal 1, c multiply 1 plus d multiply 4 because of this 4 here, equal to y2 because these two here correspond to the second position here. I do the same for the rest of the data. I have these four conditions. Now, of course, it's boring to solve these four conditions, but as before, I can calculate, for instance, A from the first one. I can I can calculate C from the second one. I plug in A here. I can plug in C here. Believe me, I will obtain B equals 0, D equals 0. We can look a little bit together at these calculations. The calculations are boring, but it's not so difficult. Again, we have seen now 3 times we can build these 4 conditions, and then we have to work with the condition which I have, calculating, for instance, A from the first one, C from the second one, and then plugging in here. For instance, here, if I plug in A, this A here, I have 1 minus 4B plus 3B equal 1. We can see that minus B is equal 0. This means B is equal 0. And the same or the similar consideration can be done for D. Once I have A, B, C, and D, I can build the matrix, which corresponds to the transformation. This matrix here reflects the transformation. Now, kernel. I have to look for element x and y, which has transformed into 0, 0. This means row multiply column means x equals 0. Row multiply column, x2 means 2x equals 0. No, row multiply column, row multiply column. I have 2 conditions. But for each y, why I am writing for each y? Because I have condition y. Y is not constrained. Look here. Y is not constrained. This means the kernel of the transformation or the null of A is 0, y for each y. Or if you want, 0, 1 multiply y for each y. This means not only 0 is transformed into 0, all elements characterized by each y. This means not injective. Not is clear is not injective, no? Because not only 0, 0. All elements characterized by each y. This means the vector, all elements characterized by the direction. You remember the definition. This is the direction. Parallel. No? Everything parallel 0, 1 is transformed into 0. This means not only 0, 0. Conclusion, not injective. Not injective. Dimension. Dimension means, remember I told you last time for Christmas, the theorem of the dimensionality. I will come back on this next week when we will see another concept, surjectivity. At this moment, I didn't tell you. This means I'm not able to explain this last line of the slide. But we will see next week. I will reconsider the dimensionality theorem. And we will introduce surjectivity, and then we will do exercise on injectivity, surjectivity more in depth. For the rest of the program, I also think this semester what I propose, we can also do the last part of the course. Sometimes I did. I would like, if you agree, dedicate to the differential equations. Anyway, next week, nullity theorem, dimensionality theorem, again on surjectivity, and we are introduce the, excuse me, again injectivity. I will introduce surjectivity. I will do some exercise on this dimension aspect and so on. And then we will see the last part. What do you think about differential equations? Do you like? Do you know? Do you know? But you don't like. Okay, if you don't like, we can do. So the goal is at the end that probably you will like. Anyway, next week, it could be that I will dedicate just one block. We will see. We will see. In any case, I will go more in depth on this dimensionality, injectivity, and surjectivity, because surjectivity I didn't tell you. Huh? I didn't tell you. Okay. We will see about next week, 2 blocks. Independently what the calendar says. Okay. But is it possible to block, or do you have a lecture? Because today is unclear what we have. No? It's unclear. But anyway, to restart is okay, 1 block. To restart is okay, 1 block. Okay, from home, thank you really to be here. We will see next week with the 2 blocks. And if you have a question, I have time for you. Otherwise, we will see next week at the same time. I am here, nevertheless. Let me stop the to record.